Bismillahirrahmanirrahim. Welcome to the new session. Today we will work on design of 50,000 gallons water tank. We will use ETAB 2016. So let's start to design a 50,000 gallon water tank, overhead water tanks. In the design of water tank, we will first calculate the volume, and then we will convert that volume to the gallons. So first of all, the let's see, go to the Google, change this gallons to CFT. This is the formula online. Suppose we want 50,000 gallon water tank, so we need a volume of 6648, say 7,000 or less. So we have to design a water tank having this volume, this cubic feet. So now we will select the size of the tank, the interior size of the tank, so that we can achieve this cubic feet of volume. Okay, so suppose we need this 6,684 cubic feet. Now let's volume of circular tank. So this is pi r square into h the height, but let's directly calculate this tank. This we have this 9. Suppose we need 6,680. We will assume 6,700 cubic feet volume. Let's say we say 25 feet length, and diameter, let's say 25 feet diameter. Filled, let's say we fill it up to 7 feet. Now calculate the volume. So this is total capacity. used gallon is 21,000. Actually total capacity is this one, but the filled volume is this one. Now in liters we have this 3,47,499. so we need 50,000 gallon volume. So we need area of the volume of the tank having 8,700 cubic feet. So this is the horizontal cylinder. This, suppose we say just we assume this one diameter. Sorry, we need this. The length is suppose 8 feet is the length. The diameter is like this one. Now let's see. Now the filled volume is like this one, 6,733. This is a cubic feet. All in the cubic feet. So like the total height is we can say 8, but we filled it up to 7 feet. Suppose if we want to increase, so then we have to choose other one. Suppose we increase this one up to 30 the dia is 30 feet. This they will win 7,000. We need 8,000. Let's see, make it 33. 7,900. Okay, make it fill 8 feet to make it. Okay, this is 9,000. Is more. So we have 7.5. Let's see its volume. Are 8,700. So we need a tank having this diameter 33 feet and which is filled up to 7.5 feet. Now let's come to the model. Let's choose open a file, a new model. We need interior diameter of 33 feet, having height of 755 feet, filled with water. So we need some freeboard as well. Let's see. Use from a model file. Suppose we use in a model. Any model we can use. This is already one of the model available. So let's see. Now we need 33 feet spacing. So the in X direction spacing upgrade or total number of grids we need. So we want to keep the grid spacing equal. So for this, suppose we need 33 feet dia up the tank. So for safety we will add 1 feet more. So let's say this is 3 grids in both directions. The spacing between the grid is some, let's say 11 feet, other is 11 feet. Now the height, total height, come to the height. One will be the bottom story going in the foundation. Let's make it 10 feet. Then from the initial or from the plinth level, we need typical story height as we want to make it 10 feet. Number of stories, okay, usually water tank is at a height of 60 feet or 70 feet, like to provide the water to all the buildings. So let's make it total number of stories 7 stories. So 70 feet it will be up from the ground. So make it okay. So this is the model has been made. So this is 3 grid. Okay, 3 grid mean that this is 22 feet. We will make another grid. So also we should know about if we want to add another grid in the existing system, how we can make the grids. So we can make it right click on this model and modify grid system, then you can add here. So this is this spacing, grid spacing. So make it another grid, make it 11 feet here. Okay, one here, add here, add one more, so 11 feet. So one more grid was added. Now make it okay. Come to the grid system. Now this is 3 by 3 grid. So this is 11 11 11 33 feet center to center, and this is as 11. So this water tank will be having the capacity of 8,700 cubic feet, and will having approximately 50,000 gallons capacity of water. Okay, this is the grid system. Now let's see the 3D. How will it look? This is the water tank, the grid system. This is the top and this is the bottom. Okay, the spacing we have 10 feet height, so this is we are now 70 feet height. Now first of all we have to define the material. Come to the material. So making material, already we have some specified material here. Suppose we want to use here 4,000 concrete, 4,000 psi concrete. Okay, so this is 4,000 4 psi concrete available. Okay, unit weight is 150. It's obviously understood. This is the mass per unit volume in pounds square inch per feet raised to power 4. This is the modulus of elasticity. Modulus of elasticity is very important, so we have to calculate this one. How we can calculate? So we have this formula for this, that under root fc prime into 2, then we can this is linked with the strength we can put here. This is 4,000 psi. So for 4,000 psi strength we can calculate this one, 36,000 05000. So this is the elasticity formula. One should know that we have to use this one. Let's see, this is the 4,000 psi strength. Now we will use grade 60 steel here. So grade 60 steel has this property. These properties like 490 is its unit weight, then its modulus of elasticity 29 raised to power 6. This is the strength we can show here. These are the strength, the minimum strength, tensile strength maximum, and the expected tensile strength. So this is the properties. Let's see. So we define the material of concrete. We need concrete, yeah, and steel. Okay, next let's see, come to the section. We need columns here, slab here, and beams, and then we have to apply the loads. Let's suppose we want to use the column size. Here we will start from 18 by 18 inch. If it works, it's okay. Other we will increase to 21 by 21. If not, then we will go for 24 by 24. But let's start from the bigger one, so that we can be on the safe side. We will define 124, 121, 118 by 18, and the beams as well, the bracing beams. So this is the elevations you can see here. Define material sections. Come to the section. Then here a lot of sections already defined. Okay, this is a beam 9 by 15, beam 12 by 18. All these are predefined. Let's use a column of 24 by 24. If you want to add, you can add anyone, add copy of property, you can use add new one property. Suppose I add a new one property, so like here, these are the sections available. You can use this concrete section solid or circular or this beam. So let's suppose we are using concrete as rectangular. If you want circular column, you can add like here. So this will be selected, but we want to use rectangular columns. Okay, this one. Let's see the properties. Select, this is column of 24 by 24 square inches. Okay, column. Now this is 4,000 psi strength, or we can use another. We have C4 KSI. Okay, 4 KSI. This is the we already defined there. This will be the color, and this is 24 by 24. This is now come to the multipliers. Make it here as per code. Make it 7.70%. This is for the rupture behavior. Then come to the rebar selection. This is grade 60. Okay, this is column. Okay, already it's okay. Now we can use number 6 bar, number 8 bars. Let's use number 6 bar here. Number 6 bar here, number 6 bar here. Okay, and now this use here number 3 bar. Okay, now make it okay. So column defined. Okay, then come to the beam. Beam section already defined. Suppose we have a beam of 18 by 18. We want to modify it. See, this is 2.4. Make it 3 KSI. 3000 psi strength we will use here. This is 18 by 18 section. Okay, this is the multiplier. This per code. This is 60 grade, 2.5 top cover, bottom cover. Okay, done. Now, okay, it's okay. Or material defined, properties defined, section defined. Now come to the slab section. Suppose we need a slab. Okay, so for the bottom we need, suppose 12 inches slab. Modify this slab as is 10 inch. Use 3000 psi strength. Then make it like concrete. Okay, this make it 10. Always used slab as shell 10. Okay, it's done. Okay, done. Now come to the plan to apply the columns. Okay, so the columns, it's easy. We want, like, we actually, this is a square tank, but in the volume calculation we used a circular, so we will make it circular. How? This is very easy. So first of all, assign the columns to the select all stories, select columns, select here. You can select columns from here at 24 by, yeah, suppose 18 by 18. I select 18 by 18 columns. Okay, so select it, make it okay, here, 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 and here. Okay, so this will be now converted to the circular. Like, we can make it circular very easily. Suppose if it's 3D, so these are the columns assigned to the tank. Column assigned. This is in circular shape. So now we need to connect with all these columns by bracing beams and with like slab. So let's suppose we apply the beam as well. Okay, so the beams, let's say select beam. We can provide beam of 18 by 18, or suppose anyone. Suppose let's provide this beam 18 by 18. This is okay. Now these are the beams assigned Now we want to connect this one, but this we have for this we will use this line command. Maybe 18 by 18. Like this we can assign the beams. Beam assigned. Okay, clear all. Now 3D. So the beams assigned in the column assigned to the tank. So this is typical tank, circular tank, and you can see like this. So let you can move it. Okay, so this is the typical tank. Now the next step is that on the top slab we need to assign the slab on the top and like the top roof cover. So for this actually we assign all the beams to all the floors. Now what to do? The second last floor we need to make the things as per our requirements. So let's go to the plan, and this is actually the sixth floor, this one. So we need here a slab, assign the slab here. So the slab is available here. Okay, we need to, on the bottom slab is we want to make it 10 inch. Okay, this is the slab, bottom slab. This is the slab. Okay, bottom slab. So you can see now like the slab was assigned. Was unfortunately we selected all the floors. Oh sorry. So we will like make it to just one floor. Now let's make it for the one floor. Basement. So we need no need here. Remove from here. Remove from here. Select this one, this one, this one, and this one. This one not. This one. This one. Okay. Okay, we need this one. So delete. Now come to. Now the slab is only in the 6th floor up to the 760 feet. Okay, now come to the plan 60 and assign the load here. Now the issue is that the technical point is that how much load we will apply on the slab. So we need to calculate the water load on per square feet. Okay, so the height of water in 1 square feet is like we selected, you can see like this, we need 7.5 feet. Okay, 7.5 feet water, cubic feet water, we will make it like the weight of this one in the pounds per square feet. So how much weight will it insert on this one. This is one of the way. The second way is that we will calculate all the volume of the water and will divide on the area. So we can like calculate per square feet weight. Suppose we want to know, let's make it easy. Suppose we want water weight vs safety pound per square feet, pounds per SFT. Volume of water. Now we know that DC tap water is 62.4 per cubic feet. Okay, per foot is this one per volume. So we are having 7.5 cubic feet. Now we can convert it easily. Calculation. Suppose foot of water to suppose if we suppose 7 foot of water, you can say this is pound per square feet, like this one. If this is 7.5, so you can say that 7.5 foot of water is equal to 468 pound per square feet. Okay, so if we apply this load on the slab, this will be the water, but let's suppose for safety we go for 500. Okay, now select this slab, and apply, assign the load, the area load, uniform load. How much? This is SDL, make it SDL. Okay, so this is in 0.5 kip. This is actually kip, so we will make it like this. Applied load on this one. Now this is 0.51 applied. Now assign live load as well here, because some worker will work here and we need some live load as well. So live load will be like this. As per code, live load here comes to be 20 pounds per square feet. Okay, applied. So now you can see the loads here. How much load applied? So uniform live load 20 pounds, and superadded imposed load is 500 pounds per square feet. Okay, this is the load. Now you can see it like in 3D form. So this is actually the beams and the slabs, all the now come to the top floor. The top floor is also, so we assuming this top floor is that this is on 10 feet height, having 1.5 or 2 feet this freeboard. So make some dead and live load here also. Suppose make it uniform live load 20, it's okay, and uniform dead, put here also some dead load, because for the insulation and for the treatment, make a load of 40. Okay, or you can make it more as well. So this is the load applied. Now it's ready. We have to run the this. We have to check the earthquake load as well. Like suppose we did not touch that one because we got the properties from the other model and it came directly here. if you want to check the earthquake forces and the loads, so you can check here load patterns. You can see this is UBC 97 we are using. Compatibility is with the ACI 14. Okay, now this is actually the zone 3 sub. We are going to zone 2, or you can select anyone, zone 1. So this is zone 1, suppose. Okay, this is all stories. We are making it 5.5. That's intermediate moment resistance frame, because this is zone 1, and in zone 1 in A and B, like we have 5 zones, so you can select any one of these. Suppose we are making it in the zone 2, 2A, 2B. Okay, so this is 2A. So 2A, like suppose we are taking this one 5.5, or you can make it more in the X direction. Okay, for water tank we can make it 1.25. The other one you can select, modify 1.15. You can make it 5.5. intermediate moment resistance frame. Okay, sorry, we did not change other one. 1.25 import spectrum. Okay, now this is the loads applied, all the loads checked, combination made. Now before going to run this model, like we applied the loads beam. On the beams we did not apply any load, but let's suppose there is some like some small load, because the workers will work, and these will be used. So one of the other thing is that we have to make wall here. Okay, wall here, so we need a wall, RCC wall here to cover this, and that will also apply some load. So let's select this one, make it like this. Suppose we need some wall, so we can draw a wall, quick draw a wall here. We can make it a wall of suppose 12 inches. You can put it here in the plane. Okay, so the walls already fine. So the walls applied, so then the other tank is confined, and this wall automatically will insert self-fed on this beam. Okay, in the other beams, if we can also apply load, but suppose we don't have any load. Suppose we don't have any wall load, so these are enough. Now we will go for the analysis, and then we will see the results, what happened. Maybe there was some error. So actually the model will give you some values, and you should judge it. If it's are in the range, so it means it's okay. If not in the range, it means there's some mistake, some error. So let's see, let's check it, what happens. Select all, and first of all, before running any of the model, we need to mesh it, mesh the beams, then select all, and also apply mesh the area as well. So floor mesh area. So all these should be meshed. Okay, so it's done now. Now it's ready for to run the model. Let's see what happened. So let's make a save it, overhead water tank 50,000 gallon. Okay, this is the water tank. We name it when we save it here, suppose we make it here. Okay, we make it here, saving like folder here, overhead water tank. Okay, saved. Now it will run. Let's see its results, what happens. So the analysis is complete now. We can see the shares in the other moments as well here. Suppose if we want to see its behavior, it's like you can see the beams are visible here. You can see all these, suppose, and you can one can like display the forces and the stresses, like these are the moments. Suppose combination 5 decon 5, suppose we want to use it. So you can see like these are the moments. These are the moments, you can see it. Suppose 8.4 like this. So all these are in the range, seems in the range. These are very nominal and very like it's reasonable. See, these are the columns. You can see like here. You can see all these. These are the moments. You can see. Okay. Now let's come to the design. If we design and we will see the results and the sections and the steel, so then we can decide like see if there's any error or it's okay. Okay, so it's done now. These the steel, this is 1% steel, showing 1% steel, like 24 by 24 is 3.2 square inches area. Suppose these are if we make it so, oh sorry, okay, all the moments, all the steel area is 1%. Okay, 1% steel. This is the beam steel, you can check it all. So suppose if you want to check the beam moments, you can see here, this is the BB18 and this is the right, you can right, these are the specified station. You can select all these summary, you can see. Okay, see, like these are the beam summary, like these are. Suppose if we want to see the moments and all, design moment is 15.4. Suppose bottom steel, top steel is like this one 28, but this is in kip feet. Okay, so it's minimum, and minimum will work here. So these are on the concrete properties. Okay, now deflection is very important here in the water tank. Suppose make it like this. So in here, what we have to do, analysis give you 1% steel and the model is okay, there is no any error, okay, etc. So you can assume it's okay, normal, it's normal, so you can proceed. It's design. This one column shows failure. Let's see where is this column. Maybe there is some error. This one column shows failure. Like let's see which one is this one. This one. This is over stress. It shows that if someone have like this results, this is over stress. This is actually not over stress, but there is a error in the model. This column has not been like placed in the right place. This is out of the grid, so that's why these beams in these columns are like over stressed. If you click on here, So like see, the longitudinal reinforcement is over stressed. This is very astonishing. It should not be over stressed. Like see, so this column is in the free area. This is not connected to the beams and not even to the like other system. So that's why it give you this is Decan. Let's see. Let have a look on here. What, where is this one? This is D3. Okay, come to the plan. Let's see where this column is getting. D3. Okay, so this is the model, and like suppose, sorry, this is the model D3. Okay, this column is actually giving you a failure result. This is actually not failed as because all the other, it means there is a good news that suppose if this column is not working, your water tank will withstand with all the other columns. Suppose there are like 4 plus 4 8 10 columns, 11 columns. So this is a 12th column. This column we need to like make it in the corner. So if we make it zoom, so we can see it. You can see it. This column is out of the grid. That's why this is giving you like results not correct. Okay, this is done now. And suppose if you want to change this column, this is very easy. Suppose select this column. Select this column and make it, delete it. Now this beam, actually this beam is actually, let's see, assign a column here, 24 by 24 column here. Okay, this is the grid. So now this column has been assigned here. Okay, this is 24 by 24 column, but this is other one. Let's see what is the issue. This column's color is why changed. Let's suppose we have another assignment as well for this column. Okay, this is 14 by 14 inch. Okay, now come to this column. Make it. This is green. So it means that these columns we selected are not according to the this 18 by 18 column. Let's see its properties. This is 18 by 18. Oh, good. So it means that 18 by 18 column works. So we need not to put the here. So I was assuming that this is 24 by 24, but this is 18 by 18. This is good news. But the 18 by 18 column works here. So it means that our model is good. And let's suppose make it here. Now this beam needs to be corrected. This beam as well. We want to make it, delete it, and this one beam like BP 24 18 by 18. assign this line drawing. Okay, this one, great. Okay, I remove this one. Now assign this column here as well. Okay, assigned. Now again run this software. Assign mesh, select all and make it mesh frame section. Okay, okay, now run it again. Let's see its results, what happens now. Okay, now here. So this is actually some tips, some important tips. So if someone want to make a water tank of his own desire, up to 30,000 gallons, 40,000 gallons, he can make the same procedure. And like this actually tutorial, not a practical one. There are many things we need to be incorporated, but this is a simple way to show you this one. So now all columns are passed and the steel is okay. No one is no beam or column shows failure. Okay, so it's done. And if you want to make the drawing, structural drawing, so you can make it here. The drawings can be prepared as well. Okay, so it's okay. Thank you so much and for